Good afternoon, everyone, and welcome to the fourth in a series of webinars to celebrate British Science Week 2021 and the theme of Innovating for the Future. I'm Claire Willis from the North East STEM Ambassador Hub, and I'm going to be introducing today's speaker, Paula McMahon from Sir Robert McAlpine, who is going to wow us all this afternoon with engineering. But first, a little bit about Paula, as sometimes I just don't know how she manages to fit everything in. Paula is a civil engineer who has worked on a variety of projects throughout the world, including the Thames Barrier and the first nuclear power station built in this country for decades. She's an experienced and enthusiastic STEM ambassador who volunteers and helps students with the leap into the real world. She loves people who invent and has even travelled to London to see the Red Bull soapbox race. Paula has contributed to several events promoting diversity in all forms and is also very passionate about the need to address the climate crisis. Along the way, she has gained many awards and accolades, and you can see those on a shelf at the back. And she's also on the Northern Power Women Future List. She is passionate about engineering and is going to talk to us today about just how exciting it can be by showing us a range of cool engineering innovations that I am sure will amaze us all. Don't forget to type any questions you might have in the chat facility and include your school name, and I will try to ask Paula as many as I can at the end. So, without further ado, over to you, Paula.
Thanks, Claire, for that lovely introduction. So I'm going to share my presentation so you can see. We are going to talk about engineering to wow. So, as Claire mentioned, we're here to talk about innovating the future and what engineers do. But before that, let's have a little bit of a welcome. So Claire's already introduced myself. I'm also going to be helped in this presentation by Maria and also Mimi. Let's hear a little bit from Mimi.
My name is Mimi Mosu and I'm a civil engineer at Sir Robert McAlpine.
Excellent, thank you, Mimi. And there'll be some other people that we'll hear from that are from Sir Robert McAlpine and also from other places all around the world. So what we're going to talk about. So it's British Science Week and we're going to talk about innovations. But I think engineers are the ultimate problem solvers and innovators. So we'll find out more about engineers and how engineers will shape the future for everybody. So we'll talk about what's engineering. We'll talk about how important engineers are. We'll have a look at the different types of engineers because there's lots and lots of different engineers. We'll have a little chat about busting some of the myths of construction, and we'll have a look at some exciting projects and engineering innovations. And then we'll obviously have our questions at the end. So as Claire said, if you put them in the YouTube chat, we'll get to as many as we can before we finish off. So, engineering, what is it? So we're going to look at these different types and I'm going to explain sort of how fantastic I think it is and the future of it. So let's ask Mimi and she'll give us a little bit of insight into why she thinks engineers are important. But we'll also have a look at some websites such as Tomorrow's Engineers, which is now on the NEON website, NEON Futures, and have a look at what interesting engineering is. See if you can see a theme through all of these different things. So Tomorrow's Engineers believe that engineering is exciting jobs that make a difference. They say that the work that engineers do affects billions of people. It's creative and hands-on. It's about solving problems, designing and improving things. They make a point that engineering is behind absolutely everything. Everything from your smartphone, hairstyling products and the lights that you switch on and even the shoes on your feet. So if you enjoy science, maths, design and technology or even computing at school, you might be able to be an engineer that's designing anything from cutting edge technology to providing water in drought-plagued countries. So have a look at the NEON Futures for more information on that. But let's see what Mimi wants to say. So I asked Mimi,
can we live without engineers?
No, we cannot live without engineers. Sorry, I didn't mean to laugh. Because I think in that split second I actually thought of the world without us and I just thought there'll be nothing here. 1, 2, 3. No, I don't believe we can live in a world without engineers, because engineering is all around us. It's the basis of our being.
So interest in engineering said basically that engineers are not only important on what we've done now, they're becoming increasingly more important. So we're becoming more and more dependent upon technology. So engineers are required more and more. And if you have a look at interest in engineering, you can see that engineers are getting involved in agriculture, which is farming, which is where your food comes from, education, and also the health sectors as well. So in answer to the question, how important are engineers? Well, they're needed now, they're needed for the future. And so I think, and I hope you agree, that engineers are very, very important. So let's have a look at what engineering is.
You find things made by engineers everywhere. If you look around, everything you see, your car, your toaster, your shoes, your house.
The building you go to school in, there was a civil engineer involved in that. The computers that we play on, there was a mechanical engineer, an electrical engineer.
Paint, you name it, anything. Toilet paper, shampoo, food products.
Engineering is all around you.
Engineers are everywhere.
I think it would take somebody with a really powerful growth mindset to accomplish things like this.
Because, you know, you can't just think about it, you have to actually think about it, you know, because those things are really hard to think about.
You would need to have problem-solving skills.
It's just a matter of having a little curiosity and the drive to do something to help the world. I think sometimes we can be stereotyped as you have to be nerdy, or you have to be a boy, or you have to look a certain way, and I don't think that's true. I think anyone can be an engineer.
But what do you think it takes to be an engineer? So have a think of that question while you're listening to this, and maybe you can ask some questions at the end relating to that. But anyone can be an engineer if you've got that problem-solving mentality, if you're good at the maths, computing, if you like that sort of thing, then engineering's for you. So there's lots of different types of engineering, and some of them were mentioned in that clip. Mechanical, environmental, biomedical, computer, agriculture, electrical. I'm a civil engineer, and there's lots of different types. So let's have let's have a look at some of them different types to explain a little bit. Can't go through all of them because there's so many different types of engineers. So there's mechanical engineers. They say they build the world around us, from anything from the tiniest nanotechnology through to cars, buildings, aeroplanes, and even space stations. So it's a combination to study it of math, science and computing, but also study of machinery, how things work, how you can manufacture and make things, and not just make them, but maintain them as well. So they keep on working for years and years and years. So it's a limitless subject, which plays a role in everything from vehicles to cities and energy to artificial intelligence. So military, healthcare, and everything in between. And that theme of being involved in lots of different things and spreading across lots of different types of things that get built, designed and maintained is pretty common through lots and lots of different disciplines of engineering. So let's have a quick look at electrical engineering. Our electrical engineer will tell you about the day in his life and explain that he looks after a plant where it's almost like a mini city, and he loves his job. And you'll find that if you look for lots of things on the internet, if you look for YouTube clips, role models, that it's very much people that are enjoying the job and find the variety and the fact that it's different every day. They really, really do enjoy it.
From any given day, I have this wide range of things that I can work on and ultimately learn from and gain experience from. So it's not the same thing every single day. You have to come in with the game day mindset, because some days are gonna be a challenge, but that's really what I like. I love seeing things come from just an idea to paper to real life. And you watch it literally from every single step until boom, we have a substation with motors. My name is Charles Nimnu, and I'm an electrical engineer. An electrical engineer at a refinery manages and operates the power system of that refinery. If you think of a refinery as a neighborhood, you have a substation or your power source that comes to your neighborhood. We then design and distribute the electrical power to each household or each unit in the plant. It's kind of like a balancing act too, where people can work on it safely, but at the same time have power keep flowing all around so they can keep going out to the units. It really requires a lot of analyzing of the power system, knowing how it runs, and then changing it to fit what you want to do. I wear 2 different hats. First one being a project engineering hat, second one being more of a maintenance engineer. I get the freedom to be creative and design things how I like it, per our standards, of course, but I do have a lot of flexibility, and that's really one of the things I really appreciate.
So biomedical, a lot of people wouldn't even think that engineering's included within sort of the medical field, but what do people do that have unfortunately lost a limb and need an artificial limb? Then that's where biomedical engineers come in. So again, the word is there, it's called an interdisciplinary field. That means that it's lots of different disciplines. So it's not just one thing, it's not just a boring job that you do day in, day out. There's lots and lots of different things involved in many of these sectors of engineering. So the biomedical engineers look at the mechanical engineering, but in combination with biological systems. So that's basically the human body. So they'll look at biology, engineering, physics, chemistry and maths to better understand how people can basically live a better life. And again, that's a theme that's for every type of engineers. So he's civil engineering, my personal favourite, that's what I am. Civil engineering, again, covers lots and lots of different things. Without civil engineers, you wouldn't have water to drink, you wouldn't have electricity, you wouldn't have the building that you're in, you wouldn't have roads, trains, or anything like that. We say we build infrastructure, and infrastructure is the things that you need to basically live your life. And again, we design things, we build them, which is construction, and we also maintain them.
What is civil engineering? Civil engineers combine creativity with imagination and technical expertise to design our built environments. But as a civil engineer, what will you do? You'll be designing sustainable buildings and bridges that bring people together. You'll be developing transport systems fit for our future. You'll be benefiting humanity by providing clean water, energy, food and shelter. You'll be building a world resilient to climate change and natural disasters. Civil engineers are improving the quality of the built environment for all. Are these things you want to achieve? You might become a civil engineer if you like developing ideas to change the world, applying maths and science in an imaginative way, collaborating with others to work through challenging tasks, questioning how things are designed and built, using technology to find the most sustainable solutions, and seeing your ideas turned into reality. Studying civil engineering involves learning how to be a designer, developing the skills to tackle the world's sustainability issues, taking inspiration from experts in industry and academia, carrying out experiments to see how materials and structures behave, extending the boundaries of what is known through research, going on field trips to enrich your learning. By doing these things, you'll gain more than civil engineering theory. you'll have skills in design, problem solving, project management, and creative thinking. You can work in industries like structural and architectural engineering, water engineering, geotechnical engineering, and transport and infrastructure, preparing you to make an impact on the world sustainably.
So I think engineering is totally fantastic. So the E in STEM is absolutely my favourite. And I think, well, it totally wows me every day. But let's have a quick look at construction. So lots of people think construction, building things, is actually a very, very dirty thing to do. And lots of people, when you say engineer or construction, just thinks of a hard hat and a high visibility vest. But there is tons and tons of jobs in construction, and construction sites aren't as mucky as what you might think. So let's have a look at, so if you just look like the Sir Robert McAlpine as an example of a builder, you can have a look on our website, and we've got lots of different things there. And yes, there's people in that picture wearing hard hats, but if you actually look at our construction sites, they're not that mucky.
What does it take to build Britain's future heritage? We've been building for nearly 150 years, continually innovating, developing and evolving. We never stand still, creating some of the world's most iconic structures that will leave a lasting legacy. Delivering projects big and small, safely and efficiently. Minimising our impact on the environment. Improving the way businesses and people interact. Supporting communities to develop. And inspiring future generations. Here, every single person and their expertise counts. Working together to succeed. We are Sir Robert McAlpine, and we are proudly building Britain's future heritage.
But you can see, just looking at the variety that Sir Robert McAlpine do, basically, can you imagine a world without engineers? The Olympic Stadium, shopping centres, airports, and everything. So again, this is a common theme through all types of engineers and engineering. This is what we do. We design, build, and maintain. So this is just a quick look at our website to look at different things. So this is the sort of design side of our business. So even though we do build things, we have to have design to help build things. We need to make sure that that we have support, because things that get built have things that you end up seeing. They're permanent things, but they also have temporary things that need to be designed to help them stand up whilst they're being constructed, because safety's got to be totally at the forefront of everything we do. The main thing we do, though, is definitely build, and there's lots and lots of different projects. So some of them you saw in the video, but there's lots of different things there. And again, you can have a look on the website. But shopping centres, places where people live, places where people work. The Royal Albert Hall is a great project. The Royal Albert Hall is a really old building that needs to be refurbished. So we need to bring it into modern times. So it has pipework and things, so it can be you know, kept warm. And you'll see the video coming up, but you'll see from this video that we have to plan things quite a bit, and this is the same for any type of engineering. There's lots of computer work that goes into planning these sort of works. Then big yellow things there are props. They are temporary works that we make sure that people in that construction site can be kept safe. So imagine working on a project like that. super cool, and it will be used by thousands and thousands of people in years to come to watch all sorts of different concerts at the Royal Albert Hall, which is a really lovely historic building, which is cool as well because it's round. I think it's cool. So again, lots of different things, and although that's a construction site, there's not that much dirt and muck. It's very clean, very well organised, because we can't have it so it's unsafe for people. We need to have it so it's nice and clear so people can walk around. And yes, people are wearing hard hats and high visibility to make themselves visible to other people, but they're certainly not the mucky building sites that you might imagine. And if you're a civil engineer, this is the sort of project that you can work on. Drainage there, everybody needs drainage in their own houses, in the buildings that they're in, and there's lots of different things. So again, I'm going to stop that there, and concrete, civil engineers do a lot with concrete.
A normal day for me is mainly management based. I also do setting out and quality checks. I host coordination meetings with the different trades on site to make sure there aren't going to be any health and safety issues. We also prioritise works for the programme, look ahead for any potential issues or delays and try to mitigate them where possible. We also get feedback from the teams. I do think my job is exciting. And there are always new challenges and puzzles to crack. And when you solve them by yourself or as a team, that's my favourite feeling. Engineering is so versatile. I don't know what I'm looking forward to most in the future, but I know that a lot of doors are open to me, and I like knowing that I'm not tied to the same job, that if I change, my career can change with me.
She knows that lots of doors are open to her, and she knows that if she changes, her career can change with her. And that's the same with lots of different types of engineering as well. It's very, very exciting that people that work in it, but it's exciting, and they know that it's versatile, it's flexible, and we can change. Because we have to change, because we're serving the needs of what people need, and that changes all the time as well. So maintenance as well, this is actually the project that I work on. And so we look after the road and the bridges and the lights and the trees and the grass and everything else. And every engineer has to think about the maintenance of everything, whether it be a smartphone, even the shoes that they design, everything needs to be maintained. And the mechanical engineers say that that's what they get trained in as well.
Hi, my name is Megan. I work in construction as an engineer and I wear a hard hat.
Hi, my name's Lucy. I work in construction as an office manager and I do not wear a hard hat.
Hi, my name's Richard. I work in construction as a design manager and I wear a hard hat.
I wear a hard hat every day and I love it.
So construction sites aren't as dirty as you might think. Then there's lots of different construction sites that we work on, including, as I've said, the Olympic Stadium, and also putting a retractable roof on Wimbledon. Now that's an innovation. So a retractable roof is something that gets taken on and off. So when it rains, in Wimbledon, they can actually put the roof on. And that was a really cool project, I think.
At Court 1 Wimbledon, we're putting a new retractable roof on the existing Court 1. This also includes extending all of the slabs on the lower side of the building and creating new hospitality areas and food courts. My role on the project involves all of the works above level 40, which are plant areas, and the main element being the retractable roof itself and the cladding associated with it. A lot of preparation has gone into this project, from the large crane that we had to lift up the roof trusses. We needed to erect a large 600-ton crane. This is over a suspended slab, so it involved numerous temporary works on the floors below, relocating of the client's sprinkler tank. The truss lifts were a great success. We did a lot of work with all the subcontractors involved in the years preceding the actual lifts themselves. We had checklists in place to make sure it could be carried out safely. We had weather watches to make sure that we were within weather windows, because there are very strict criteria for lifting up the trusses. We had road closures, and the whole team were involved in making sure exclusion zones were adhered to. I started work with Sir Robert McAlpine as a student during university. I was a sponsor student for my final 3 years, and then when I graduated I got a job in the London region and have been here ever since. It's great working on an iconic project. When you tell people about where you work, they're always interested and always wanting to know a bit more. This project has been very challenging from a technical perspective. It's improved my technical knowledge of steelwork and movements, and just really tough logistical challenges.
But there's lots of other types of really cool projects that's in engineering. Just look at them buildings. They're not boring. Most of them aren't even made out of red brick, like you would think that a building would be made out of. They're not square. Some of them are tall. Some of them even come back on themselves. Some of them have holes in the middle. And lots of them have different innovations. There's one of them buildings there that even just turns constantly. So if you're in a room, you'll get a different view every hour of the day, which if you don't think that's exciting, well, let's have a chat, shall we? So looking at some innovations, just the wildest innovations of 2020. Again, you could literally spend all your life looking at all the different innovations. So there's lovely, cool buildings there, but engineers have also invented food, such as ice cream that doesn't come from cows. That is a really cool building that has a walking trail. It has a slope on it, so you can actually put on sort of roller skate type skis and roll down it. And it's also extremely environmentally friendly, that building as well. It doesn't have any, it has carbon neutral, which is something that we're going to have to consider more and more. Here's some more food related things. That's bacon that doesn't come from a pig. And there are other things that engineers have invented, things that you wouldn't even think that an engineer would get involved in. Okay, so there's some low calorie sugar. Who wouldn't like the idea that they can have something sweet without the calories? But even art projects need to have engineers to be involved. These things wouldn't stand up at all if they didn't have somebody thinking about the problem of making sure that they stay where they are in all weather conditions. Just think how windy it gets sometimes, and the different temperatures and things. So as temperatures get hotter, things expand, and as they get colder, they contract. So all of them things are problems that need to be solved, and engineers are the people that solve them. So to summarise, engineers are problem solvers that design, build and maintain just about everything. And I totally love engineers. Well, engineers are not just problem solvers, we're innovators as well. So solving a problem often requires you to create something new or innovative. So just to explain that a little bit, invention is something that somebody comes up with completely new. So think of the ice cream. So ice cream already existed, but it's innovative to think that you can make ice cream without needing a cow. Yeah, so it's using things, it's not making things from scratch, it can be making things better. So engineers, they may not have been called engineers, were the inventors of the wheel to begin with. Yeah. And they won't have been called engineers to begin with because they'd have just been somebody that was a good problem solver and an inventor. But imagine a life without a wheel. What have we done to innovate that wheel all the way through society? You couldn't do anything without a wheel at all. You obviously couldn't use a car or a train, but it's more than that. There's wheels inside of other things that you won't even see. Inside of every motor is wheels inside of it. Then there's concrete. Just think about concrete. So engineers invented concrete, but we've innovated in concrete technology over many, many years, and it's now stronger. We can make it lighter. We can make it more sustainable, so more environmentally friendly by doing things like replacing cement with other things to make it still as strong, but not adding as so much carbon to the environment. So Mimi, who was in the pictures before, she looks at concrete all the time. She looks at the quality of concrete. So she loves concrete. Engineers invented the train, and that picture there is quite an old picture, but think about what trains look like now. They don't really look like that anymore, and so, you know, we've innovated all the time, and now you get different types of trains. And TVs, engineers invented TVs, and again, they don't look like that anymore. They're now much thinner, and they sit on your wall more like a picture, and you can get smart TVs that have technology, and you can use them to link to the internet and everything. Just think how much they've been innovated over the years. And obviously, looking towards the future, we're going to do more and more in terms of innovations and in terms of digital technology and artificial intelligence and things like that. So again, just typing in searches for innovative engineering. We've got 3D printing that we can do. We've got train tracks that float. Who would have thought it? If that doesn't make you go, wow, I don't know what does. Superconductive materials, so things that conduct electricity and heat very quickly. Hydro, solar panels, all sorts of things that are smart rings, so you could pay for things with just having a ring. Everything to do with energy, drinking water, all sorts of different things. So engineers are innovating all the time. And who would have thought one engineer would even be looking at folding paper in order to think how you can have a bridge that's more innovative, a bridge that you could fold, put on the back of a truck, and then use it any way you wanted to. Honestly, if that doesn't make you go, wow, what will? So looking to the future, we're going to be looking more and more towards technology and looking, you know, making it more and more in our day-to-day, and maybe even looking further ahead, we may even be looking more and more into going into space. So who knows, the future, what's it going to look like? So sustainability is something that we all need to think about, and here's some sustainability innovations in civil engineering. So we're looking at plastic roads, so taking a product that's a waste product and using it for something that we can is useful and it doesn't use oil. Green roofs, which is putting grass and things on roofs. Floating homes, who wouldn't want to live in a house that floats on water? Vertical farming, so looking at things that makes better use of the land by growing things up instead of along, and harvesting rainwater. So instead of all of that rain coming on your roof, going down into the drains, let's harvest it and let's use it for things like flushing toilets. Again, there's going to be lots and lots of engineers looking at technology, so digital twins, so making a computer program, a computer package that looks like the building, so we can have lots of information embedded in there, so we can try things out, and it's a good record of everything that we can try things out before we build it, and it's a good record of everything that's been built. Again, we get that artificial intelligence where computers will be doing thinking for us, and lots of other things including robotics and printing. And they call it disruptive engineering because they change things so much, they disrupt the way that we work and how we're going to think and how we're going to live going forward. So a good example of that is the smartphone. That was a disruptive technology. So before the smartphone, before the iPhone, who would have thought that you would have carried around in your pocket something that would replace maps, the telephone, computers and everything? So the future of engineering, there's lots of different things that you can look at in the future of engineering. Aerospace engineer on Mars, global food, smart cities, everyday electronics and sustainability and software engineering. So there's lots of different things that we know that the future of engineering is going to help us even more than it does today. So I think we can all agree that engineering totally wows. It's essential now. It's creative. It is definitely innovative. It's very varied. It's for absolutely everybody, and it's needed for the future. So at that, I am going to hand back to Claire and say, do we have any questions?
We certainly do, Paula. We've got lots of questions for you. So first question, Paula, why did you become a civil engineer?
So I sort of fell into it, and I think you'll find if you ask many people that when they were, you know, how they ended up in the job, they'd say the same. But the reason why I fell into it is because that's where I had my experience at school. So I did a week's worth of experience when I was at school at my local council. And I totally loved it. It's totally, this is what I want to do. And so I applied for being an apprentice at the local council, and I got it. And that apprenticeship was for a civil engineer. So I didn't set out to be a civil engineer, but in speaking to adults and in speaking to my careers officer, we realised that sort of engineering was what I would probably enjoy, because I was good at problem solving, good at maths, I like sciences, and so that was a natural fit. And so it was my work experience that got me the job, and it was the job that made me a civil engineer.
So really important to, even though, you know, you're quite young when you choose which works experience placement you want to do, it's obviously really set you on your career and your future career, hasn't it? So
it has, yeah.
It's really important for the students out there to think about a works experience placement.
It is, yeah.
Second one, so have you found it difficult as a female in what is often perceived as a male-orientated industry?
I wouldn't say difficult. I think there are some difficulties, because a lot of people think that that you're a bit unusual, and sometimes if I've walked on a new building site, they'd like, look, and go, oh, who's this? But I wouldn't say it was difficult, like really difficult. But yeah, there are definitely differences, and there's lots of people that find it a surprise, but that's less and less now. I mean, I'm pretty old. I've been doing this job for 30 years, and so obviously it was a lot more unusual when I was doing it. But since there's a lot more girls in the industry now, it's a lot more common and it's easier. So for example, when I first went on building sites, there wasn't any girls' toilets, and boys' toilets were pretty smelly. So I used to have to go to, like, I used to have to find like a shop or a cafe that I'd have to ask if I could use their toilet. But now, not a problem. All of the sites, certainly in our company, have, you know, dedicated ladies' toilets. They're lovely and clean.
That's a bonus, isn't it? Wow, no ladies' toilets, goodness. But we have, as you say, come on quite substantially since 30 years ago. You don't look that old, Paula. So if students, the students that are listening, how would they, what advice would you give them to get into engineering? So what GCSE and A levels should they concentrate on taking?
Right, so first and foremost, the route I took was the apprenticeship, and then I did an ONC, and then I did a degree. But you don't actually have to do that route. There's many different routes into engineering, and you don't have to do a degree at all. There's different levels that you can stop at. So you don't need a certain sort of a grade really of anything, because you can work to most people, as long as they're reasonably okay in sort of maths and sciences, can work towards being an engineer of some sort. My suggestion is that you speak to people at home and people at school, and you'll do lots of research. So research, look at some of the websites that I've linked to, and look at others as well. So look for the different sectors. What do you fancy doing? Look for apprenticeships, because apprenticeships are really good, because you'll learn while you're earning. But the thing is that any of this, you're not necessarily going to get your plan A. So make sure you have several options. So you might choose, say, an apprenticeship as a first option, but there might not be anybody offering them near you or in the area that you want, or you may not just get the job. You know, these things happen. Not everybody can get everything that they want. So then look at local colleges and things like that. Now, each of the colleges and each of the courses and each of the apprenticeships will have their own entry requirements. So you've just got to check to see if you meet that criteria. And life is full of a combination of hard work, which you obviously should always strive to do, but also a bit of good luck and a bit of opportunity. And you can enhance your options by looking around more and doing this research and putting forward the best CVs and the best application forms that you possibly can. But as I say, sometimes things just don't work out. You were just unlucky and you just didn't get that job. So make sure you have some fallback plans. But the routes can be varied. You can go through the academic route, you can go through the apprenticeship route, you can stop and start. I know plenty of people that are not doing the job now that they started off with leaving school. So don't worry if things don't go to plan. Life's a journey. So just take every step as it comes. Look for the end goal, but and just look in detail at the next step and see what happens.
Brilliant. So it's just about seizing opportunities, isn't it? And you know, you say those links that you've got in your presentation are really great links for people who are considering going into a career in engineering. You know, use those links, use the information that Paula's talked about today. A question from Jeremy Harmsworth. Paula, what's your favourite project that you've been involved with and why?
Wow. So I've been involved in lots of different projects. I loved working on the Thames Barrier because that's a really iconic structure and I got to go underneath the river in London. So that's pretty cool. I loved working on the nuclear new build stuff because I was involved at the very early stages. So all the work that I did as the sort of lead engineer on that job has shaped that whole project. Hundreds of millions of pounds worth of project has been shaped by decisions that I made, and who wouldn't love that? But in my heart, I love working now at Sir Robert McAlpine, and my first dealings with Sir Robert McAlpine were on the SNF site at Billingham, where I was the design manager and then I was the construction manager, and Sir Robert McAlpine actually worked for me on that project. And so by working with them, I liked the company, and so I ended up applying for a job at Sir Robert McAlpine, and so now I'm working on the A19 project. So I would say every project I've enjoyed in different reasons, and the ones that have left a legacy are the ones that you sort of really look back and say, I'm pleased I did that.
Fantastic, yeah. And I mean, some of those images that you showed, Paula, the engineering, it's just phenomenal. It's, you know, the things that you can build and do is just absolutely incredible. And the students that are watching today, you know, they could be part of that in the future, you know, a construction that we haven't even thought about at the minute. So, you know, brilliant. I'm going to ask you this question, but I think you're biased. How good is it being an engineer?
Well, I said that today, if I don't prove to you that engineering is wow, because it's just brilliant and it's the best letter in the STEM word, then I think I've proved that. I think it's pretty cool being an engineer.
Yeah, fantastic. Lady, so from Baden Powell Primary School, so what problems have you solved? So I mean, you've solved loads of problems, Paula, but I guess sort of which ones sort of, which maybe the most difficult problem that you kind of thought, oh goodness, how on earth am I going to be able to solve that? So what's been I guess the biggest challenge, I suppose?
Oh, that's hard to say because there's been so many. So as engineers, you solve problems every day, really. Some of them are obviously very, very small, but some of them are rather large. It was quite cool on the SNF site, and the problem was we had some massive tanks to build. I mean, tanks that were much bigger than Olympic-sized swimming pools. And how do you build something that's so big and so buried in the ground? So the solution that was come up there was a 50 metre, so 50 metres is huge, your whole school will probably fit in it, diameter sheet pile wall that we sunk into the ground and then dug everything out. And it was that tall, we had 4 flights of stairs going down to the bottom of the excavation. So that was pretty cool.
Wow. So I'm sort of going back to Sanonia, you know, I know you're very passionate about diversity and women in engineering. So there's a question from Sarah John here. I don't know if you know the answer, but it might be a percentage that you might be able to. How many women go into engineering these days?
So it's a complicated-ish question because it totally depends on the sector and even geography in the country. It varies dramatically, but roughly speaking, there's about 12% female engineers, but again, it varies per sector and even per discipline within each sector. So for example, in construction, there's less than 1% of people on the tools that actually work on construction sites as a construction worker. And some sectors have 45%, but generally speaking, it's sort of 12-ish, 14-ish%. So round about 1 in every 7 throughout all engineering types are female. But given the fact that as a population, we're ever so slightly more females than males, that's quite a bit off the mark. We're approximately 51% of the population are female and 49% are male. So we have a long way to go, ladies, to get ourselves so we're equal compared to society. And that's where I would like us to be. I would like the workforce to reflect society. The reason being is we make so many decisions every single day that affect society. If we don't have the amount of the same percentages of people in there of all different types, then we won't be making decisions that represent them. So for example, if you're building a building, if you don't have somebody there that knows what it's like to, say, be in a wheelchair or not have, to be partially sighted, how do you fully accommodate their needs, So that's the reason why it's important to have a diverse workforce.
Yeah, great. I think my dog's got something to say about that.
I think we agree. The dog agrees.
Well, a really great question, actually, from TIG Federation. So how do you make yourself stand out from the crowd and get the jobs, and have you ever gone for a job and not got it?
So the second part of the question, absolutely, gone for a job and not got it. Yeah, again, it's a combination of luck. You don't know who else you're against. They just might have a better set of experience than you and be more suited to the job. These things happen, which is why you shouldn't always rely on plan A. But to make yourself get the best possible options for anything is all to do with preparation and planning. So just remember that the people that are going to be looking through those applications, those CVs, what's on that piece of paper or entered onto the computer screen is all they know about you. Yeah, they don't know any more about you. So make sure it's the best possible version of yourself. Don't just say, I'm leaving school and I'm predicted this number of GCSEs. Who are you? What do you like doing? Why are you applying for that job? Have you looked at that company and said you're interested in working for them because you like that project that they've worked on, because you want to make a difference? So make it so it's a bit more personal, and so it gives that best possible version of you. Get people to read through that. So, because often you read your own stuff and you read what you think it says instead of what it actually says. So get other people to give you constructive criticism. And prospective employers may well do an internet search on you. So just make sure that anything that's out there in the public domain, on your social media profiles and things like that, have a look through it. And that joke that you had between you and your friend that may have been absolutely hilarious at the time may not sit very well with a potential employer. So if you do all of them things, you are massively increasing your chances of being successful in whatever you do. But always have plan B, plan C, and even a plan D, because plan A doesn't always work out. It hasn't for me, it won't for you, Claire. There won't be an adult, I think. There'll be very rarely have an adult that'll say everything that they wanted worked to plan.
No, you're right, and that's life, isn't it? And then we've all been through a terrible 12 months, but that's really shown people's resilience and the challenges that we've all faced. So, that's great advice. And I guess sort of if we've got young people sitting there going, I really want to do what Paula's doing, what sort of piece of, if you could just give them one piece of advice. I mean, you've given them loads of advice there, but just one piece of advice, what would you be saying to them?
Go for it and follow your dreams, totally and utterly. And do all of them other things that I've said to increase your chances. But there will be people along that I've had people that's told me I shouldn't be doing certain things because I'm female, because I'm younger, because I'm whatever. But be yourself, follow your own path. Don't follow everybody else's. You might want to follow other people, that's fine. But if make it your decision and follow your own path and your own dreams.
Brilliant. Well, I know we're so lucky to have you, Paula, because you know, this week, well, every week for you. So we're really delighted that you could take some time out and share your experiences. Actually, there's a one last question, which is always the one you get asked, and we haven't been asked it yet, but here we go. What's the expected salary in a job like yours?
So again, that is really is a how long is a piece of string. One of the good websites to look at is the .gov website for finding apprenticeships. I'll dig out the link and I'll get it added to the back of that slide set. And there's a couple of good websites that explain to you what different types of jobs are and what the expected salaries are. I think for a civil engineer, I think they say that the salary is something from like 28 to 65,000. Again, that's a massive range because it totally depends on job function, experience, qualifications. You know, so I've been an engineer that's been responsible for 200 and odd people on site. I've been a design engineer that's been responsible for 50 people in offices. I've been responsible for hundreds of millions of pounds worth of work on certain days. So obviously them sort of jobs attract a higher salary, but I've also been a design engineer where I've sat there and done my own work and worked for other people when I was younger and had less experience. So it really is how long is a piece of string. But I will ensure that there's links added to the back of that slide pack so you can have a look to see what the different salary ranges are for different types of jobs.
Brilliant, brilliant. So so the Paula's presentation we'll have on our YouTube channel, and we make sure all those links either get directly to you teachers by your email that you gave when you registered, as well as having it hosted on our YouTube channel. So thanks for joining us this afternoon, and Paula, to yourself once again, thank you so much for your time. You're 100% dedicated to everything that you do, and you're quite rightly have got all those awards behind you. I'm sure there's others that you've hidden. So don't forget, everyone, join us tomorrow morning at 10 o'clock, particularly those people who are runners. So we've got someone talking about a little device that he came up with that sort of helps you with your running gait. And hopefully everyone is enjoying British Science Week, and we'll see you back here tomorrow at 10 o'clock. And we also have a session tomorrow afternoon as well. Okay.
Is that Laura from Greenology?
That's Laura, yeah.
Laura is well worth watching.
Yeah.
Laura's a really good speaker. Yeah,
she turned down James Bond for tyres, a recycling plant in Edinburgh. So I'm sure she's got a very interesting story to tell. So that's at 1 o'clock tomorrow afternoon. So thanks again, Paula, and thanks to everyone who's watching.